My name is Michael Morehead, and I did an investigational study rather than an experimental study, and I investigated essentially why rainwater is not collected on a pretty larger scale than it should be, because it's easy, it's not expensive relative to like solar energy for power, and there are quite a few areas in the United States that suffer drought or water infrastructure collapse. The results of my investigation were basically that it ended up being legislation and in some cases a cost and life price to live, basically cost of living, affected the ability to implement it on a mass scale. So my goal when I set out and learned this, I changed my testable question to what is a cheaper and more effective way to do it. I actually built a model. I used rain gutter and just a normal sill, and I was able to filtrate it much simpler and cheaper than it would be for a traditional rainwater collection system. In a traditional one, there's numerous tanks and there's numerous steps, and then you choose when you want to use the water source, which I found to be kind of wasteful, and it's also really detailed, so there's a lot of things that can fail. The pipes can erode. Whenever it's sitting in a tank, it might erode through the tank because it functions the same as a sewer plant or anything like that. So anything that sits in there for a while, it will eventually erode it. And then you also have to choose when you want to activate it yourself. In my design system, it would just implement itself directly into it after being filtered. So you wouldn't have to do anything. You'd turn on your faucet the same way you would normally, and it would go on. There is a valve shutoff that you can use as well. That way, if it rains and you choose not to use your system, you can turn it off and it won't even go into it. The reason that this became a really feasible idea that I noticed is in areas like Flint, Michigan is a great example right now, and then most places in California, they average anywhere from 30 to 40 inches of rain, and that yields a maximum of 40 gallons of water per year, which doesn't sound like a lot, but in areas like Flint, Michigan, an average family right now has a gallon of drinking water a week. It's a pretty large problem. In conclusion, I kind of realized that it was a little bit of both legislation, cost, and efficiency of the system that rendered it not being used on a national scale and then international scale as well. And I found that to be kind of something that can be solved from both sides, and I did write a piece of legislation as well to fix this problem. Thank you.